No, but because it helps you practice. But if you do a problem and you're like, I get this, I don't need to do all of them, then you're safe. You're not going to get any points off. So that should take a little pressure off of us for the time, okay? Also know that Monday and Tuesday are test review days, and it's one test review over 2 days. And the test is on Wednesday. You're doing that in 1 day, and I'm giving us 2 days to do the review. Plenty of time to talk, make sure we go over anything, any of the homework questions you want me to help you with, whatever you need. So we'll be able to breathe a little bit Monday and Tuesday, okay? All right, so let's get started. Talking about symmetry a lot today, and there's 3 ways to evaluate a polynomial's symmetry: by looking at it, that's the easiest way, algebraically, which is easy too, and then in a table of values. So there's 3 ways. We're going to do 2 of them in the notes, and then I'll do the first 3 homework problems with you, which are the table ways, because it's really easy. We don't need to waste double time on that, okay? So even and odd are the only 2 types of symmetry we're going to do in this class. So you're either even, you're odd, or you're neither one of those. That's it. That's all the symmetry we're going to talk about. And so let me just skip to the graphs first to explain it, and then I'll talk a little bit more about those 2. But I want you guys to recognize even and odd functions just by looking at it. There's no math. It's just knowing some knowledge, okay? So let me start out by telling you guys that this is considered odd symmetry, okay? We also call it origin symmetry, and I like it because of the O's, all right? So first thing of 2 that has to happen to be an odd symmetry is you have to go through the origin, okay? So if it doesn't go through the origin, you know it can't be odd, okay? First thing. So, yep, we got that. And then the other thing is another O word. You know, I like little things to help me remember, like decreasing and concave down, whatever. Opposite quadrants are identical, okay? So 1 and 3 are the same, and 2 and 4 are the same. If you look, this is quadrant 2. It's got this going on, and then we have the same thing happening in quadrant 3, okay? I'm going to give you some more examples of those in a second, but let me just go over all 3 of them first, and I'll put it all together. So that's odd. Even is also called y-axis symmetry, and it's pretty simple. Your y-axis splits the graph into 2 equal parts. It has to be the y-axis, not the x-axis, nothing else. If I folded that graph on the y-axis, all the points on the left would touch the points on the right, okay? So that one's pretty easy to tell. And then this one is neither. You can't even see a pattern in there. It's not the same left to right, and it certainly isn't the same here and here, right? Those are 2 different, they don't match up at all, right? Another thing about this one, to help you understand the difference between, let me write either, is in the odd one, quadrant, like for example, quadrant 2 has a point at -1, 2, right? That's this point right here. And in quadrant 4, we have one at 1, -2. So they're complete opposite signs, everything. That's this point here. Okay? So just to throw some other examples at you, let me just draw another one. What do you guys think of that graph? No, not even. Odd, yeah. Because if I fold it on the y-axis, these would not touch. But opposite quadrants are congruent. What if I'm sorry, say it again. Okay. But what if I made the graph like this? Neither. Yep, neither one. A parabola, right, at the at the origin, pretend it's a perfect one. That would be even, right? But if I take that same graph and I go over here, it's neither. Even though a parabola has its own symmetry, right, just like here, the right side and the left side are exactly the same, right? This is symmetric. It has an axis of symmetry that serves as its, like, folding line. But when we talk, this is why I love this example, when we talk about even and odd, it's specific to the x and the y axis, okay? So you'll always, when you're judging these graphically, it'll always be on a coordinate plane. It won't just be, like, written on blank space, because it has to do with where it sits on the x and the y axis, okay? So let's talk about how to do it algebraically. And this is going back to, you probably did in Algebra 1, Algebra 2, but here it is again. This is when we're going to use these two concepts, okay? what these mean is this. To test for even or odd in a function, so algebraically, we always plug in a negative x. Everywhere we see an x, we're going to put a negative. What you get determines if it's even, odd, or neither. So what even means, when you plug in a negative, you're back to the original. What that means is no signs change. Okay? And over here, all signs change. So I'll come back to that in a minute, but if you want to write those there just as a reminder when you're studying or something. And I'll explain this. There we go. There we go. So easy, easy, easy. All I'm doing is plugging a negative x in everywhere I see an x. And then I'm going to simplify it. And let's remember our really, really simple ways of knowing if these are positive or negative when you simplify them. Even numbers, positive, right? For every 2 negatives, you get a positive. Every 2 negatives, we get a positive. For odds, it's going to always be negative, because if you have 3 negatives, 2 of them become positive, but you always have that leftover negative. So make this nice and easy. Negative x squared, that's going to resolve itself down to positive. And then negative x, the first power is negative, and then minus 12. Okay? So what you do is you look at your original function and the one we just simplified, and you look at the signs. What you're looking for is, did all signs stay the same? Did all signs change, or neither of those situations? This one, go term by term. X squared is the same as x squared, right? They're both positive, stayed the same. But when we get to the next term, x is positive, x is negative. We have a sign staying the same and a sign changing. Who cares what the rest is? That immediately made it neither. It's got to be all or nothing. Either all the signs stay the same, even, or all the signs change. So let's keep going. So negative x to the 5th minus 4 times negative x to the 3rd. Okay, odd, negative. Careful here. Order of operations, we do our exponents first. Odd is negative, right? Odd is negative. But then when you multiply a negative times a negative, you get positive. So evaluate the original to our new one. X to the 5th, positive. Then it changed to negative. So we have a change, right? Negative to a positive. Change. Both signs changed. Odd. Remember our graph? Negative 1 changed to positive 1. Positive 2 changed to negative 2. And the last one. Positive, positive, right? This is positive, that's positive, times whatever's in front. So 2x to the 4th positive, stayed 2x to the 4th positive. Negative 6x squared, stayed negative x squared. All signs the same. So that would be even. If you were really desperate, pretend I said you have to tell me if it's even, odd, or neither. If you answer it correctly right now, you can graduate. You can skip the rest of the years. If you were desperate and you were like, I have to get this right, you could plug it into your graphing calculator and look at it. So if you understand it better this way, maybe you're more of a visual person, you could look at the graph. You're starting to get more comfortable with your graphing calculator, so you're going to start learning ways to figure things out using your calculator to back you up. Here, yeah.
One small thing.
Sure.
I think it's negative x positive.
On which one, A, B, or C?
On A.
So, because when you plug in a negative and you do it to the second power, it becomes positive. Negative times a negative is positive. Okay. Do you agree that I'm just looking at the signs here because I don't have a value? What if I said x was negative 2? When I plug in here, right, I would put negative 2 in there. What do I get? I get a positive answer. The squared stays there because we don't know what x is. We didn't plug a value in at all. We don't know what x is. We're just saying what would happen if that number were negative. It would become a positive number. When you square anything, it's going to be positive. Because we're not, understand, we're just looking at signs. We're not simplifying. We're not like saying what is y when x is 2 or something like that. We're not trying to find the value. We're just evaluating the signs. No matter what I plug into a squared, no matter what, whether it's negative or positive, you're always going to get a positive answer. That's what this is saying. We're going to have a positive answer. Okay. No. And we're not doing that one. Okay. You're going to see this again here in a second. All right, go to the next page. This is a really easy problem. Probably the first time you've ever seen it, because the first time I've seen these, but they're super easy. This is a table of values where we can use our method we've used before, first differences and second differences, to find out what the degree of the polynomial is. So just, in an equation, you know what the degree is. You just look at the highest exponent. On a graph, you'll eventually be able to tell. But in table values, there's another way to tell what the degree is, what your biggest exponent is. And that's using first differences to start with. And you can subtract your y values through the table left to right or right to left. I'm going to do right to left in that order because later on it will matter what order you do it in. But truthfully, right now it doesn't. So just for the sake of us having the same answers, just understand I'm going through and doing right to left. And I'm going to put these numbers here. Now, every single one of you knows what the word subtract means. I don't have to sit here and explain to you, oh, I'm pressing a button on my code. Okay, you understand 96 minus 30. Nobody's like, where'd she get 66? I don't think so anyway. So if you want to just steal my answers right now, we don't have to all sit here and type these in. But what I will say is make sure, I would do a couple of these because I'm still seeing students mess up with their negatives. Even at this level, we have kids that are they can understand the hardest word problems and understand everything, but then they make a mistake on their negatives. And I have my little things I make mistakes on too. But on something like this, it's so bad if you do. So you want to be careful. So understand, if you're going to use your calculator for these, that's a negative 14 minus negative 30. Or you could have thought, all right, minus and a negative become a plus. But just make sure you're okay getting these answers, okay? If you feel comfortable with them, just steal mine. First differences, okay? What we're looking for with our differences is all the same number. If all of these numbers were 16 or 2 or negative 5, if they were all constant, the same, this would be a linear function. First differences means exponent to the first, x to the first power, linear. It's not a degree 1 polynomial. So we keep going. Let's do our second differences. Again, you can steal mine. I'm doing 66 minus 32 all the way down to 2 minus 16. And I'll put those numbers in here for you. Clearly, not all the same number. So it's not a quadratic either. It's not x to the second. So you can see, well, let me not say that yet. And then the last one, I'm doing the same thing. Can't find a pen. Okay. I'm just doing these. And in this one, you will get 12 the whole way down. So our third differences are all constants, right? They're all the same. So this means this is a cubic, the third power polynomial. The degree 3. The biggest power will be 3. So what I was going to say is, if you mess up in that first row, it will affect the numbers in your second row. And if your second row is messed up, you'll never, you could be, don't go past 3. If you get to the third differences and it's not the same, you made a mistake in your subtraction. That's it, okay? Because the concept's really easy, right? Find the row where they're all the same. That's the power. Good? Kind of neat. I mean, I can't even wrap my brain around why that works, but it does. All right. Second to last thing, making this a lot simpler. Write a polynomial function, blah, 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 in factored form. And the directions in the homework are going to read exactly the way they say it here. you are just going to know when you get to this problem, you're going to do it the same way I did it in the notes. So whenever this happens, guys, like I change something in the notes, change it in the homework too. What I model for you is how you'll always do it, okay? So this is super, super quick and easy. This is going backwards from where we went yesterday. If you remember yesterday, sometimes we were given a polynomial and we had to factor it, blah, 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 got factors, set them equal to 0, solve, there's your zeros. Well, we're working in reverse here. We're given zeros. We want to write it in factored form. So think back to yesterday. If you know that this is a 0, and it was given to us, how do I make it a factor? Come on, how do I make it a factor? You see me look at you, William? Add 3 to the other side. Yeah. And just think of what you're doing. You're going in reverse. If I gave you this as a factor and I said, what's the 0, you would set it equal to 0 and solve it. So we're just undoing the solving of the equation. So x plus 3 is one of our factors. Okay? It has a multiplicity of 2. What's that going to do to this x plus 3? Put squared, a 2. Because there's 2 of them. Do I need to show this work? Oh, no, you don't have to show that work. When I bring -1 to the other side, I get +1. And when I bring 4 to the other side, I get -4. And these are both multiplicity 1. You can put the 1s there. It's kind of a rookie thing to do, all right? You could put equals 0 at the end. You could have put f of x equals this. But that's the factored form. What she wanted us to do, but it's not on the AP test, it's not going to be on any of my tests, it's like FOIL this all out, make it an actual polynomial, blah, 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 long. No, we don't need to do that. Okay? So that's all you have to do. Be able to take zeros and write it in factored equation form. Okay? Last thing, these are the last 2 homework problems. So if you've been feeling pretty good about all of the stuff that we've done so far, like this is pretty easy, depending on what you're thinking. The last 2 homework problems are probably the newest stuff, and one of them is on your test, okay, for sure. The other stuff could be on there. I don't remember right now, but I know for sure one of these is on your test. You'll see it on the review on Monday. And this is kind of the newest stuff. Oh, you weren't talking to me. Sorry. Okay, so what we're doing here is talking about real zeros and polynomial inequalities, okay? And this is a new notation here, but it's a really simple idea. This is asking where y is greater than 0 or y is less than 0. That literally means above the x-axis or below the y-axis. Think about if you graph a point, just an ordered pair. When are you above the when are you above the x-axis? When your y value is positive, right? When are you below the x-axis? When your y value is negative. That's what takes us up or down, is the y value. So all this is saying is where is our graph above the x-axis and where is the graph below the x-axis. It's fancy notation for just saying that idea. And that's what we're going to do. So we're given, in example 13, a function that's in factored form, like we just did a second ago. What we're going to do is decide where the zeros are, what parts of the graph are above the x-axis, and what parts are below. It's really, really simple. We already know how to find the zeros. Set these equal to 0 and solve, right? This is opposite of what we just did in the other example. So we're going to have zeros at -3 and 4. We have 2 4s, but remember, we don't write them twice. And just so you know, zeros are also called critical values. Okay, so you might hear that, and you'll see why in a second. And here's how we find out what part of this graph is above and below. So watch. We're going to do something called a sign test. Draw yourself a number line. It does not need to be perfection. And what you're doing is putting your critical values on the x-axis, our zeros. So that's it. You don't have to fill in all the other numbers, but you do want to put them least to greatest. You wouldn't put 4 first and then -3. And we're going to do a sign test. So what this means is you're going to pick numbers in the intervals of the x-axis. Think about it. A number line is just the x-axis, and the y-axis is, well, never mind, we just didn't draw the whole thing. I'm going to pick some numbers to the left. I'm going to pick one number to the left of -3, in between -3 and 4, and to the right of 4. And this will make more sense in a second. So you could pick any number, by the way. Any number you want that's to the left of negative 3. If negative 478 is your favorite number, use it, okay? Anything that's less than negative 3, I'm just boring. I just pick the next number. But it doesn't matter. It really doesn't. Again, anything between these two, I like zeros. Zeros are nice and easy to plug in. And then any number greater than 4. Okay? Any. It doesn't have to be the same as mine. And we're doing a sign test here. What this means is we're going to plug negative 4 into the equation, and we don't care what the answer is. This is not solved. I'm not graphing this or anything. I'm just wondering, am I going to get a positive or a negative answer? Is y going to be positive or negative? So this is how I do it. And you can choose you do it like right as much as I do. It's up to you. So I'm plugging negative 4 into that first equation. Negative 4 plus 3, I'm going to get a negative answer. I don't care what it is, but it's negative. If you wanted to actually solve it, you could, okay? And then when I plug negative 4 into the second, negative minus 4, who cares what I get? Why did I say who cares what I get in here? Because when you square it, it's always going to be what? Positive. So no matter what number, negative 4, 0, 5, any number I plug into the second set of parentheses, it's always going to be positive. And when I do a negative times a positive, I get negative. So I'm going to be negative. All of my points to the left of negative 3 will be below the x-axis. Okay? Next test number. Plug a 0 in. 0 plus 3, I'm going to get a positive answer. 0 minus 4 squared, we already decided, is always going to be positive. And a positive times a positive is positive. So this middle one is going to be positive. Above the x-axis. That's all that means, above. And lastly, 5 plus 3, positive. 5 minus 4, who cares? You're always going to get a positive there. Positive times a positive, positive. We're all positive here. So what we just found is that from let me do negative first. From negative infinity to what is negative? Negative 3. And you can use brackets or parentheses. I prefer parentheses, but I've seen both. So it's just like increasing and decreasing. You can use either one. And then we're positive in this interval and this interval, but aren't they consecutive intervals? So you could totally write them as two separate ones. It's fine. Or you could just say from negative 3 to infinity. There's no break. It's all positive. Don't graph this, but let me just make a point to you so you understand what you just found. Here's negative 3. Here's 4. What we just found is that we have a graph that's negative from negative infinity to negative 3. Then we're up here for a while, actually forever. That's a rough graph of what you just did, which you don't have to graph, but I want you to understand. Negative from negative 3 that way, and then we're positive from negative 3 on, above or below the x-axis. That's all this is talking about. Okay? Last one. Sorry, we have to do one more. That one we did a second ago was an equation, equal sign. This one's an inequality. You can have less thans, greater thans, and so on. So it's almost the same, slightly different. We are going to use a sign test and everything, but we're actually asking for a solution here. What we're asking is, where are we less than 0? This is the less than sign. Here's what I mean. First thing I need to do is I need to find my critical values. I don't have my critical values. Here, the polynomial was factored for us. We set it equal to 0, found our zeros like that. Here we're going to have to factor. So the first thing I'm going to do is bring everybody to one side. Everybody's going to come on to the left-hand side. So x to the third would go first, right, because he's the biggest. He's my degree. And then we want the 4x squared to come next, right? When I bring it over, be minus. Right, so we got that one, got that one. Negative 4x would come next. I don't need to change his sign. He's on the left-hand side. He's not moving. And then the 16, negative 16, when I cross over, becomes positive 16. So I just rearranged that equation all in one step. If you needed to do it in more than one, that's fine. But I'm basically getting everybody on one side together. Exponents descending order. I'm going to factor this lightning speed because we already reviewed it yesterday. We all should know how to factor at this point. Factor out the GCF. Remember, when the third term is negative, you always factor out a negative. Our parentheses are the same, yay. And our GCS are going to give us a difference of 2 squares. So we're not done factoring. Those sneak in on us all the time. Final factored answer would be x minus 4, x plus 2, x minus 2. So we kind of started the last problem at that step. They gave it to us factored. Here we had to factor it. Critical values, also known as zeros. Set each of these equal to 0 and solve. There's no work to show, but our critical values are 4, negative 2, 2. Zeros are critical values. They're what we're going to use. They're critical to us answering this question. Sign chart. Order of least to greatest, always. That's as much work as you need to do. And pick your numbers. Pick numbers in these intervals that make you happy. They don't have to be the same as mine. They really don't. They just have to meet the criteria. Now, in the last problem we did, we were just looking for where is it positive, where is it negative. And we are kind of here, but this one's a little bit different. I wish I had written on my paper. Oh, I haven't done it. When I plug in, this is really important. When I plug in these values, there's a very specific place I have to plug it in, and that's into the original function, okay? So I have to plug into, I'm just rewriting it because I wrote over it. 4x to the third minus 16. So that's where I'm plugging in, right there. And here's the thing. You can do signs, but it's kind of confusing in these types of problems. So this is another way of doing it. And the way I'm going to show you right now, you could have done up here. Okay, you could, remember I said you could actually solve it. You could, instead of getting negative and positive, you could actually do the numbers and get what the answer is. Is the answer positive or negative? That's kind of what we're doing here. Yeah. This is, oh, thank you. Oh, that would have taken me an hour to undo all that. Okay, thank you so much. That's squared. Okay, so here's the easiest way to do it, guys. Use your graphing calculators. Use that screen. Watch what I'm going to do. I'm going to plug right into here, so I'm going to use my negative 3. So in parentheses, negative 3 to the third power minus 4 times negative 3. And I didn't really have to close my parentheses. And I get negative 15. Leave it on your screen. Just leave it there. Now plug negative 3 in the other side. So I got negative 15 and 20. What I got was negative 15 is less than or equal to 20. I'm going to write it. You don't have to. But that's what I just found. Negative 15 is less than or equal to 20. What I want you to tell me, though, is that true or false? It's true. Negative 15 is less than or equal to 20. When I plug a 0 in, that's the easiest one of all, I get 0 on the left-hand side. And over here, you get negative 16. Is 0 less than or equal to 16? Negative 16? No. It's false. And for time's sake, I'm going to tell you what, when I plugged in a 3 here, I got 15. When I plugged in a 3 over here, I got 20. Is 15 less than or equal to 20? Yep. And the last one, I'm just going to give you my answer. When I plug 5 into the left-hand side, I got 105. And when I plug 5 into the right-hand side, I get, I think it's 84. Whatever, 80-something, not true, right? That's false. So understand how we're going to answer this question. So I just did my sign test and found what do true and false mean? Where is this a true statement? Is the left side less than the right side? Wherever I said false is not my solution. I want all the places where this is true, where this is less than or equal to this side. So that would be these two intervals. That is where we are less than. This is less than this. Those numbers work and that make that inequality correct or true. So that's negative infinity up to negative 2, right? We're negative there, not negative in there. Then we're negative between 2 and 4. And then we're not negative after that. So that is where this is the solution. You're solving a inequality. Where are we less than? Right there. Could they have given us greater than? Yep. Then we would have had opposite trues and falses. That's all. Just have to read it. So this is the newest stuff. These are the last 2 problems on the homework. So if you're just going to zero in on something, I would zero in on those. We don't need to graph it, but if you want to see it, here it is again. Where is the graph? Negative infinity to negative 2, and 2 to 4. Okay? You're not going to have to graph it, but it's good to see the visual. Oh my gosh. What time is it? Is it really only 9:30? Oh, wow. You have a lot of time. Oh, look at how different that is. My second period only has 42 minutes. The bell rang when I was still talking last period. And then, so you guys have till 9:47. Okay, good. Great. You might be able to get a lot done. Let's go to the homework. And remember, I'm going to do the first 3 with you because I have something to show you. But then I will have time to walk around and answer any questions you might have that I went too fast on. So some days are like this, guys, and I'm sorry. I try really hard for it not to be like this. But the truth is, I am trying to make up time from last week. We lost 3 days. Okay. So I know my paper looks different than yours at the top, so we're in practice set 2. And the first 3 are the ones I said we can tell even, odd, or neither just by looking at a table of values as well. She writes out a whole explanation. You don't have to. I'm looking for even, odd, or neither, but I'm going to do those 3 with you. Oh, forgot to tell you. That word means omit. Oh, it says omit. It means don't do. Leave it out. It's just faster than saying don't do. Just 4 letters. Omit number 23. Don't do it. It's at the bottom of that page. You might as well just cross it off. It's just because there's 2 neithers. There's no need to do 2 of them, but you could do it. Okay, so how do we tell even, odd, or neither from a table of values? Well, look at this first one. We already know it's odd because we're looking at the key, but here's why. Look at how the y values compare on either side. So all the y values change. So you have your x values, and then look, y values all change. Or you can kind of just picture in your head, where are those 3 points? We're at 0, 0, that's important, we have to get the origin. And then left 2, up 1, quadrant 2, right 2, down 1, quadrant 4. So you're going to have matching points here and here the whole way. So you can almost sketch the graph and see it faster than looking at the signs. It's up to you. Let me show you 19 next is even. If you look, all of the y values stayed the same. Whether we had a positive x value or a negative x value, all of the y values are the same. That's even. And again, picture what this graph looks like. It looks like a parabola, 0, 0, 1, 7, negative 1, 7. They're exactly on either side of the x-axis. Right away, you would know that that's even. And this one has no pattern at all. You could even sketch that graph. It would make a mess. Okay? So no work to show on those. Odd, neither, even. And I don't know if you're going to start here, if you're going to go to the end of the assignment. I will come check on y'all. What? Sure. Yeah. Good with the 18? Oh, I see. You're 22 and 24 on the next page, huh? So like 24, 25, 26, maybe do one of them. When you get to those, it's the second differences, different, There's a quartic. I wouldn't do that one. I assigned it, but I'm not checking it. Do you really need to subtract 4 times? Maybe just do one of these. You know what I mean? Just cut down on the amount of work.